Hello, I'm out here on a Sunday on the EDM drill, working on some customer parts. The parts that I have right now, I need to make a hole that is 0.4 millimeters in diameter, and it goes down about 20 millimeters. So the aspect ratio of this hole is unusual. EDM drilling is a technology that enables very high aspect ratio holes. It's a little bit limited in that the range of electrodes that I can use on my machine, and I think are pretty common on other brands of EDM drill, are about 0.3 millimeters on up to 3 millimeters in diameter. EDM drill is also called a hole popper or a fast hole EDM. And this type of machine is commonly used to make starter holes for a wire EDM where the wire needs to go through the part. So you need a way to make a hole in the part. If it's a typical material, it's not a big deal to make those holes in a CNC milling machine, for example. But in EDM, you often run into hard materials like hardened steel or carbide. And there isn't a great process, especially when you're looking at high aspect ratio holes on a typical milling center. The goal in EDM machining is to bring your electrode close to your workpiece and to generate a spark using a high voltage signal. And the signal that gets applied is programmable. It has a voltage level, it has an on time and an off time. And the other thing that is important is to control the gap between your electrode and the workpiece. And these are parameters that you can set in the control on the EDM machine. In an EDM drill, it's a very crude and fast and rough process in the sense that the quality of the hole that you get, if you need a really precise diameter, precise roundness, you're going to need to maybe use the EDM drill to make a starter hole and then take it to the wire EDM to make your hole. But that's not the point of the EDM drill. The goal is to make a hole through your part quickly, or in this case, with this part, to make a very small diameter hole with an absurd aspect ratio. The EDM drill has a special feature where it has a pump in the machine, which is the same as a pressure washer pump. In this case, it's driven by an electric motor, and it pumps high pressure water concentrically down through the center of the electrode. And you consider it what an electrode might look like that can have a concentric high pressure water jet. It needs to have a hole all the way down through the electrode. The electrodes are usually 400 millimeters long, and so they're this long. And in the case of a 0.4 millimeter electrode, it's pretty wild to consider that it's a tube instead of just a solid. The electrode is brass in this case. Sometimes you can use copper electrodes also, but the way that the electrodes are made is they're drawn out like optical fiber, where you start out with a slug of material that has a hole through it. So a bigger diameter starting material and a reasonable hole that you maybe could drill. And then you put it in a machine that grabs both sides of it and draws it out, and does that over and over again until you draw it out and shrink the diameter down to the desired size. So that's how you were able to produce a very long electrode with a small diameter that also has a concentric hole through the entire electrode. This machine uses deionized water as the dielectric. So you were pumping high pressure dielectric or DI water down through the middle of your electrode, and it creates an effect to stabilize the electrode in the hole. The electrode's also spinning at 50 RPM or whatever the whole time, and this makes a condition where with the high pressure water coming up past the electrode and back out of the hole, and with the rotation that it holds the electrode concentric in the hole during the drilling process. And that's really the way that you're able to achieve the high aspect ratios, is to hold the electrode in the center of the hole, and while you're sort of presenting still the face of the electrode to the bottom of the hole. So the machine uses a guide for the electrode. So you'll see that on the machine there is a collet on the rotating spindle that holds the electrode, but down below that is also a guide that really positions the electrode above the part, and the guide is brought down right to the surface of the part, so you have 2 points of contact on the electrode to straighten it out, and then as best as you can, it's right there at the top of the part. The guides are made of ruby, so industrial ruby, and they're extremely precise, so a 0.4 millimeter electrode will go into something like a 0.45 millimeter ruby hole in the guide. In the EDM process, it works by bringing the electrode really close to the workpiece and establishing a gap. And the gap, if you get a voltage high enough across it, it will have an arc. And when there's an electrical arc across the gap, ultimately you're turning on and off the EDM signal at something like a kilohertz, and making thousands of these arcs per second. But you bring the electrode close to the workpiece, you apply the high voltage, it creates a spark, and when that spark gets turned off, the plasma that's there collapses and removes molten material from both the workpiece and the electrode.